Hi everyone, welcome back, and today we are going to see about the repulsion motor. So what is the meaning of a repulsion? The opposite poles it will attract each other, and the same polarity it will repel each other. So that is the concept we are using in this kind of motor for the operation of a such motor. So that's why it is called a repulsion motor. So it is a special kind of single phase AC motor, so which work on the principle of repulsion, because here the similar poles it will repel each other. Okay, so in olden days we are using such kind of motor in electric train, but now it may be outdated because of using the several kind of induction motors and some other induction motor. Now it will be outdated, and the based on the magnetic repulsion between the two poles, it is called an repulsion motor. Okay, so it will be very essential in the industry tools. So here in a repulsion motor, it is a single phase AC motor, and we are providing the AC supply into the motor. Here it start is act as a repulsion motor and runs as an induction motor. You can note it out. The motor starts using the repulsion principle. The motor starts using the repulsion principle, and it will be running under the principle of induction motor. So here, why we are starting using the repulsion principle? Here the starting torque should be very high for repulsion motor, and very good running characteristics in the running motor. So that's why we are using. At the time of starting, it will be a repulsion because it produces high starting torque. So the pickup is very high, and under running condition, the running characteristics is very good in induction motor. So it operates under the induction principle. So in the repulsion motor, direction of rotation it can be same as that of brush shift. Based on the brush shift, the rotation may be either clockwise or it may be an anti-clockwise. Okay. So here the repulsion motor is equipped with the stator and as well as rotor. Here there will be a commutator and brush assembly, everything is there. Okay, in single phase exciting winding, which is similar to the main winding of single phase induction motor. So here the rotor is distributed DC winding connected to the commutator at one end, just like in the DC motor. So here there will be a commutator and brush shift will be there. But here the carbon brushes are short circuited, not we are taking out. Okay, in conventional DC motor, the brushes are taken outside. Okay, it will be either connected to the DC supply. But here the rotor is connected to the two brushes and the two brushes are short circuited themselves. Okay, so here the internal current will be circulated in the rotor winding itself. And the working principle. So the basic principle behind the repulsion motor, here the same poles, the similar poles, it will repel each other. So based on that, the motor will operate. Here it has two north pole will repel each other, or the two south pole will repel each other. Okay, so here it will be supplied. Here it will be supplied by using the single phase AC. So it will produce the rotating magnetic flux along the direct axis. So this magnetic flux it linked with the rotor winding, and it create an electromagnetic field. So because of this electromagnetic flux or field, a rotor current is produced. So because of this short circuit rotor, the rotor current produces a magnetic flux. It is directed based on the brush axis due to the commutator assembly. So due to the interaction of stator and rotor fluxes, the electromagnetic torque is produced inside the machine. So based on that produced torque inside the machine, it may be classified as compensated repulsion motor, repulsion start induction motor, repulsion induction motor. Okay, so here based on that it will be classified as three categories. In the compensated repulsion motor, here there will be a compensated winding which is used to improve the power factor for better speed regulations. And for the repulsion start induction machine, Here, which is similar to the existing induction motor, here act as an start as an repulsion motor and running as an induction motor. Starting is a repulsion and running as an induction. Once the speed reaches around 70 to 80% of synchronous speed, then the short circuited of the commutator segment can be eliminated. So the centrifugal system gets open and again it will be continuously running with just like an induction machine. And the repulsion induction motor. So here, according to the characteristics of repulsion induction motor, the single phase stator winding, okay, so it has two separate independent winding on the rotor in common slot. So the inner winding is squirrel cage and the outer winding is repulsion or commutator winding, which is similar to the DC armature winding in the DC machine. Okay, so based on the repulsion principle, it will operate as a repulsion. And these are the few applications of repulsion motor. So here film winding machine, hoist, machines in textiles, machines for floor maintenance, printing presses, air compressor pump, fan, air pump, petrol pump, drive compressors, etc. And the main advantage of this repulsion motor, excellent beginning torque, because we are using here at the time of starting it acts as a repulsion, so it gives better beginning torque, low starting current, and wide range of speed control with a smooth speed regulations. And what is the disadvantage? At lower speed, the power factor is much less, and brushes and commutator quickly exhaust owing to heat production and arcing at the brush assembly. And this is an assessment. And repulsion motor run as single phase motor as an induction motor only when either short circuit is disconnected, stator winding is reversed, the commutator segment are short circuited, brushes are shifted to neutral phase. So put your answer in the comment section. And these are the few references. Thank you.